Hello friends, this video on equilibrium part 29 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Let's talk about pH scale. So the pH of a solution is nothing but negative logarithm of base 10 to the H plus ion concentration. So you see, if H plus ion concentration is something per mole liter, the pH is equal to minus A log H. Now the question is, why do we have pH? So as I told, if you see, H plus ion concentration in water is what? 10 to the power minus 7 mole. Right? And let's suppose we have some other acid. Let's suppose some acid. In some acid, this is water. In some acid, the H plus ion concentration, let's suppose 10 to the power minus or 3 into 10 to the power minus 2 mole. You don't know. So writing these things is very difficult, right? In 10 to the power minus 2, 3 into the power minus 2, it's a very complex thing. So what this chemist did was, instead of writing in this form, he is writing the whole thing in minus log of this value, 10 to the power minus 7. So this will give what? 7. So saying pH is 7 is better than saying the concentration of H plus ion is 10 to the power minus 7 m. See the difference. See, the concentration of H plus ion in a particular solution is 10 to the power minus 7 m. Saying this in a normal way is very difficult, right? You have to say the concentration of H plus ion in a particular solution is 10 to the power minus 7 m moles per liter. Or if you just say the pH is 7. This is pretty fancy, right? Because with this, see, 10 to the power minus 7, it is all negative generally comes. So they have put a negative sign here just to make the life simple, right? And to make these things more fancy. So if you don't put negative here, it will become minus 7. But just because handling negative value is also difficult, so they have put a negative here, right? So it's just a way to communicate that pH is minus 7. That means pH is 7. That means the concentration of H plus is 10 to the power minus 7. pH is 3. That means concentration of H plus is 10 to the power minus 3 moles per liter. Correct? And there's a pH scale. So if you see, 7 is neutral actually here, and if you go less than 7, it is acidic, more than 7, it is basic, and the maximum value is 14, minimum value is 0. Now the question is, why pH is equal to 0 is acidic and why pH is equal to 14 is basic. We'll take this in the next 2 slides. Just understand that pH is nothing but just one representation. Normally the concentration is in terms of 10 to the power minus 7 moles per liter, 10 to the power minus 5 moles per liter, something like this, or 8.382 into 10 to the power minus 11 moles per liter. These are very complex number to represent. So instead of that, what they do is they just find the minus log of this value, and that gives a very good number, maybe 7, 8, 9. So that way it is easy to communicate. Correct. So there's a pH scale. If you see in real life, if you want to find the pH, if you see the bleach which we don't use normally, your moms or your sisters may be using, the creams, that is has the pH 13. The soapy water has pH 12. The ammonia solution has pH 11. The milk of magnesia has pH 10. Baking soda used in cooking has a pH 9. Seawater, normal seawater, you go to any beach, the seawater has the pH of 8. It's a little basic. And distilled water has the pH 7. If you see the water pH itself varies. Distilled water has the pH 7, the neutral water, but the seawater is a little basic. Urine has a pH 6, a little acidic. Coffee, tomato juice, orange juice, lemon juice, gastric acid, all these are acidic. Gastric juice is most acidic, pH 1. So you see, in real life we have all these things and different pH. If you are curious, you can find pH of different stuffs around you. You can take the pH scale meter and you can find the pH of different things, leaves, water, and stuff like that. So as I told, the pH is equal to 0 is very acidic. Why it is so? Why it is that 0 to 7 is acidic and 7 to 14 is basic? Why it is not other way around? See, as I told, pH is nothing but minus log of H plus ion concentration. Correct? So now if pH is equal to 0, what does it mean? 0 means, if pH is equal to 0, that means H plus ion concentration is what? 10 to the power minus 0. That is what? That is 1. That means H plus ion has a huge concentration. If pH is equal to 1, H plus ion concentration is what? 10 to the power minus 1. Correct? So this becomes, because see, pH is equal to minus log of H plus, or H plus is nothing but pH into 10 to the power, equal to 10 to the power minus pH. Right? If pH is equal to this, so H plus is nothing but, it is log to the base 10. So H plus is nothing but 10 to the power minus pH. So H plus here, in case pH is equal to 0, H plus concentration is 1. In case pH is equal to 1, H plus concentration is 10 to the power minus 1 moles per liter. That is little less. If you make pH is equal to 2, the hydrogen ion concentration is what? It will reduce all the more. It will become 10 to the power minus 2 moles per liter. So if you see, the concentration of hydrogen ion is reducing. If you take pH is equal to 5, what will happen? Hydrogen ion concentration will be all the more less, 10 to the power minus 5 moles per liter. If you take pH is equal to 7, same thing, 10 to the power minus 7 moles per liter. If you take pH equal to 10, it is reducing, if you see, right? If you take pH equal to 14, the max value, the hydrogen ion concentration is all the more less, very, very less. So if you see in this case, the hydrogen ion concentration was more when pH was 0, that is almost 1. Right? For every mole, if you see HCl for example, so it breaks completely, right, into H plus Cl minus. In that case, if you keep 1 mole here, you get almost 1 mole of H plus ion. It's very strong acid, right? If you take pH equal to 1, the hydrogen ion concentration is little less. It's 10 to the power minus 1 mole per liter. That is almost 10% of the acid got dissociated. Similarly, if you increase the value of pH, you see the hydrogen ion concentration goes down. That's why pH equal to 0 is very acidic. If you increase the value of pH, the acidic nature goes down. There is something called pH paper which is used to find the pH. So you may have used this in the labs also. We'll take some examples on pH now. The concentration of hydrogen ion in a sample of soft drink is 3.8 in the power minus 3. What is the pH? It's very simple. pH was nothing but minus log of H plus ion concentration. And this is my H plus ion concentration. So this becomes minus log of 3.8 into 10 to the power minus 3. And this, if you solve, this becomes 2.42. This is my pH. Very easy. See, pH is nothing but minus log of H plus ion concentration. H plus ion concentration is given 3.8 into 10 to the power minus 3 moles per liter. Just put the value, get the answer. Let's take an example. You have to find the pH for 10 to the power minus 8 m solution of HCl. So it is a dilute solution. It is a dilute solution of HCl. We have to find the pH of this. So you see HCl, if you put in the aqueous, if you put water in this, what happens? This breaks into H3O plus ion and Cl minus ion. Correct? And now it is saying that it is diluted. So we have water plus water also, which gives H3O plus ions and OH minus ions. Correct? So here H3O plus ion is what? 10 to the power minus 8 mole. That's a dilution of water. Sorry, this will be 10 to the power minus 7 only because normal water here. This guy becomes 10 to the power minus 8 because it's what it says. The pH of a 10 to the power minus 8 m solution. So this is diluted. So this is 10 to the power minus 8 m only. This is 10 to the power minus 8 m. It will give you 10 to the power minus 8 m H plus ions. But it has water also. In water it is 10 to the power minus 7 is fixed. We know H plus ion concentration. Right? So if you see in this case, concentration of this guy, equation 1 and equation 2, if you see, from equation 1, the concentration of H plus ion is more because 10 to the power minus 7 is more than 10 to the power minus 8. Please note here. See, the HCl is a strong acid, we know, but it's very, very dilute now. It's 10 to the power minus 8 m solution. right? That means pure water, if you just have a pure water, this guy has 10 to the power minus 7 moles of H plus ions, but this acid HCl, even though it's an acid, it has 10 to the power minus 8 m of H plus ions. Which one is more? Obviously this guy is more, right? This guy is less. So the second reaction will rule. Second reaction will rule. Right? So in this case the pH will be this guy, minus log of 10 to the power minus 7, and this becomes 7. See, pH won't be 8. See, if you make it pH 8, 8 is nothing but basic. Right? pH, if you see, if you take this value, it comes out to be 8. And pH of HCl is 8 is too hard to understand. Right? pH is acid. So what we do, since this is very, very dilute, what we did was, we found the H plus ion concentration in pure water, because anyway we are using pure water here. So there we saw the H plus ion concentration is more, and the HCl gives a less H plus ion concentration. So anyway we'll take the bigger one, because this everything is one solution, right? This, so the pH will come out to be 7. So here you have to find the pH of the sample of vinegar. The pH is given 3.76. We have to find the concentration of H plus ions. So we have pH is nothing but minus log of H plus ions to the base 10. So this is nothing but H plus ion is nothing but, if you see, 10 to the power minus pH. Right? That is nothing but, or let's take anti-log. You can take this value also, this comes in the 10 to the power minus 3.76, or this is nothing but 1.74 to the power minus 2. Or let's try the anti-log process. So pH is equal to this value. Let's try the anti-log way. pH is equal to 3.76 is equal to minus log of H plus. So log of H plus is what? Minus 3.76, or H plus is nothing but anti-log of this, right? Nothing but anti-log of this is minus, so it becomes nothing but 4 with a dash 0.24. 4 with a dash 0.24. This is nothing but 1.74 into 10 to the power minus 4. This is a better way. You can use the anti-log.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.